Rules of indices. Right, that's called the base. The big number is called the base. Small number index. Base, index, base, index. The plural for index is indices. So what happens when you got a question like this? Right, if the base are the same, which they are in this case, and you happen to be timesing in between, the rule is you have to add the indices. So copy the base because they are the same, and then add the indices. 3 out of 4 is 7. You could do the same thing with algebra as well. If the base are the same and you happen to be timesing in between, copy the base and then add the indices. So when it's timesing in between, you add the indices. 7 plus 2 is 9. Right, if they're different, let's say you got a situation like this. The base are different, so you can't just say which one should we pick. No, for that, in that case, all you can do is just simply work it out. 2 to the power of 3 is 2 times 2 is 8. 4 squared, 4 times 4, 16. So all you can do is work out 16 times 8. You can span over to many more numbers like this. Few more like this. All the base are the same, you're timesing in between, so copy the base across and then add the indices. 3 add 2 is 5, 5 add 5 is 10. That's 2 to the power of 10. It's quite a large number. You use a calculator to work it out. What if you happen to be dividing? Let's say you can write division like that, or you can do it like this as well. These are the same. It's the same question, just written in 2 different ways. That's a division symbol. Right, if the base is the same and you happen to be dividing in between, copy the base and then subtract this time. Subtract the indices. 4 take away 2 is 2. You know that's 64. So when it's dividing, it's subtract. When it's timesing in between, it's adding. What about when you get something like this? Right, it seems a lot more complicated now. So what you do in this situation is you only just start off with looking at the numerator. Start off by looking at the numerator. So the base is the same and you're timesing. So copy the base across, and then remember, when it's timesing, it's adding the indices. Right, do the same for the bottom. Right, that 4 means 4 to the power of 1. So if you've got a single number like that, for example, that means 5 to the power of 1. If you've got a single number, anything single, it's written like that. So that means 4 to the power of 1. It's timesing, so you add the indices. So copy the base and then add the indices. 3 plus 1 is 4. So now it becomes a division problem. So the base is the same, so copy the base and then subtract the indices. 9 taken by 4 is 5. Situations where you've got brackets. So what does that mean? Well, if you want to do it the long way, it's all of that, 2 to the power of 3, 4 times. So I'm going to repeat that 4 times. So a little 4 there outside of this. So I've repeated it 4 times. Right, if you've not followed that, just think, if I've got 5 to the power of 3, that means 5 times 5 times 5, 3 times. So if I've got, I don't know, I'm just making this up now, this is, if I've got a triangle to the power of 3, doesn't that mean triangle times triangle times triangle? Well, look at that there. I've got 2 to the power of 3, 2 cubed, so it's 2 cubed, 2 cubed, 2 cubed, 2 cubed, 4 times. Right, if the base is the same, copy the base, and then because we're timesing, you have to add the indices. 3 add 3 add 3 add 3 is 12. Right, is there a quick way to get from here to here? Well, there is. You times over the bracket. The little numbers, see the little numbers there? You times them. 3 times 4 is 12. So if you've got something like this, all you're going to do is 5, 2 times 3, 6, 5 to the power of 6. That's much quicker. Well, you might face a question like this in the exam. Now what? Well, you know how to do, you know how to do this. Copy the base, and then 2 times 3 is 6. So you do the same for that. But now look at the big number. It's not 4 times 3 now. It's 4 to the power of 3. 4 to the power of 3 means 4 times 4 times 4, 64. Let's do one more. Right, deal with that bit first. 3 times 2 is 6, and then 2 squared is 4. Don't do 2 times 2. Well, in this case, it's just a coincidence. 2 times 2 happens to be 4 as well, but it's actually 2 to the power of 2. Just like here, it was 4 to the power of 3, not 4 times 3. 2 to the power of 2 is 4. So common misconception, okay, this is wrong. I've seen people do this many times. They get that bit right, but then by mistake, they put 4 times 3 is 12. It's wrong. It's meant to be that.